60%. In 2025, in just 9 years from now, a stunning 60% of the power generated worldwide will be for information and communication technology. Most of that power will go into the artificial intelligence that we use every day. That's the recommender system of your social network, the speech recognition on your phone, or eventually any of the computational tools we will be using to cure cancer. The semiconductor industry is spending large amount of money in order to do amazing chips in order to solve these low power issues and computations. But even according to them, in their own words, this is just not enough. A breakthrough technology is required. A few years ago, I met 3 very different researchers here in Paris from some of the best universities, and we wondered some crazy questions. Could we use nature to compute? Could we use nature to compute for AI? Could we use nature to compute for AI in a way that is scalable, sustainable, and fast? Well, today I'm proud to be sharing with you the answer to these questions, and they are yes, yes, and yes. My name is Igor. I'm the CEO of LightOn, and with Florent, Sylvain, Laurent, and David, we've been working hard on the radically novel hardware technology for computing. It's a mix of electronics and optics that does computation for very large data, very fast, at very low power levels. We get to also be using off-the-shelf semiconductor components. And we've been working so hard on this that now it fits into a shoebox. We do mathematically random projections, but I'm not going to bore you with the math. The bottom line is we have a coprocessor that is connected to a PC, and that coprocessor can go 2 orders of magnitude faster than a standard laptop, or equivalently be very low power for the same operation. On the business side of things, we're looking at 3 stages. The first one being that we're working on the hardware prototype, and we're continuing our discussion with the Leonardos of our time, the machine learning researchers at the edge of the artificial intelligence boom. In a year from now, we will be making available our technology on the cloud so that you and others can have access to it and do wonders with it. In 2 years from now, we will be solving problems with the semiconductor industry to get products out for the B2B market with our technology. It's a very unique opportunity for them because we're allowing some of these companies to smoothly transition away from pure silicon while retaining their IP and know-how. Our vision is pretty simple. We want to add more and more optical elements to our current product and eventually leverage the huge growth in optical interconnects we see nowadays. This is a game changer, as it potentially opens the door to an all-optical computing system. Imagine a world where computation is not limited by the power, by the environmental impact it has on us, but really by the power of our imagination. We are LightOn, and we use light to build the future of computing. Thank you.
Thank you very much.
So your plan is to build your own data center with your own hardware that you will rent as a cloud service?
Initially, yes. It has two different reasoning behind it. The first one being that we want a community that is extremely active in machine learning to use it. And we think that the best way to do that is through the cloud. They are already accustomed to do these type of things. And the second one is for us to essentially build on the technology on our side to add additional operations to the current ones we have.
Thank you, Igor. What are the first applications you're going to go for, and what's the business model behind the cloud approach?
Well, the first one, most of the computation we do right now with the operation we do is what we call data dimensionality reduction. We take very large data and we make it small. And what's very interesting is that mathematically, and there is a lot of literature behind it, that shows that somehow the objects, the smaller objects that we get out of the operations we have, has very close to the same qualities as the very large one. So you get to be able to do machine learning on the small ones instead of the large ones. And now you can do a lot of big data machine learning type of things, which now is still a big problem and remain a problem for a little while still with the GPUs and so forth. Does that make, did that answer?
And the second on the business model with the cloud, is it open source? Is it,
yeah.
Because there's a mix of IP and...
Initially, there is a segment for university researchers, the people at the edge of machine learning, for which it's going to be mostly open and free. And there is a second segment of industry-related type of projects, which will essentially be some of the initial money maker in that operation. So yeah, there are two tracks to this, absolutely.
Can you go faster than light? No, I'm joking. No, like, is quantum computing one of your competitors in the long run, or? Yeah,
we have quantum computing as competitors. Let me say two things. We also have nuclear fission. That's what I'm saying is that we have power from nuclear fission from the past 50 years, and it works. And for the past 50 years, we've been asking for nuclear fusion. And for the past 50 years, we've been asking for nuclear fusion, and we still don't have it. I'm not saying that quantum computing is there. I'm just saying that every time we are looking at this, it's still kind of 5-10 years away. So, and it still doesn't really match very well some of the machine learning.
When we look at it, it disappears.
The what?
When we look at quantum computing, it disappears.
Exactly, yeah. Part of it, yeah.
Can you describe a little bit more how it works?
Yes. In front of the whole crowd, yes, I can do that. We basically use elements of condensed matter physics. We get light in, and it mixes randomly. And when it gets out, we pick it up with a camera. And what we get on the other side is essentially a mix of the information that came in. Mathematically, we show that that operation still saves most of the information of the very large object we put in the first place. Did that answer your question? We use a natural process to essentially do that operation. So we do not have any cost associated with doing that operation. Whenever you are doing it on silicon, whatever GPU or CPU, there is a cost associated with memory, associated with having access to that memory, having access to even running the current through it. Thank you.
Thank you very much, Igor.